Okay, I just gotta show you guys this. These 100 right now are lit up very bright. Probably because this 100 is not. Um, this 100 is hooked up right now, but not tuned in. Okay, now this is where I would normally tie the two strings together. Then they don't have to be perfectly balanced. So this one is connected. This one, I disconnected this end. And I've done this in the past, but I've never showed it on film yet. You can see how bright they are. This is 100 and 100 now, but only the 100 is lit here. Now you see this end. Okay, that goes to what I can't show you, but I disconnected that end. Okay, basically it's a receiver, you know. So this one's connected to a receiver and nothing at the other end. This one is not connected to the receiver, and it's not connected at this end. Well, it's picking up the energy through this wire. So there's actually two open spots in my circuit, you know, between the transmitter and receiver, and also between the receiver and this wire. They're not physically connected. So that's just pretty cool. It wouldn't work unless I had these connected. So these are the reason these are working. But neither end of this is connected. So like I said, this has two breaks in the system, which is kind of funny. Now you know what? Let me show you this. Again, I'm at 1.14 megahertz, 16 volts output. Show anything I wasn't supposed to. All right. There's my 4 points. There's just notes. We're just looking down here. Okay, power equals voltage times current. And I'm sorry to do this to you guys. I know there's a lot of you guys that don't like math. I usually don't like to get too involved in it. I like it, but I don't like it. Anyhow, so I'm human. I could make a mistake here, okay? So, in science, that's where most mistakes are made, is in the math. So, if I'm doing something wrong, guys, let me know. Okay, power equals voltage times current. That's one of the formulas. Anyhow, all right, let's just look at this. 100 LEDs in series, what I just showed you right now. Now, in video part 2, I had 350, but let's ignore that right now. Let's just say 100 LEDs in series. Okay, 100 LEDs times 2 volts each. They require 2 volts each. Okay, now I'm positive from my hundreds of experiments that what I've just showed you, I've probably got close to 2.5 volts across each of those. Okay, at least 2.4. But let's say 2 volts minimum, okay? So you go 100 LEDs times 2 volts, that's 200 volts minimum. Okay, I'm sure I have more than that, but let's assume the lowest thing. Now, we just said, okay, now let's look at our LEDs. Okay, I have 2 volts, and move my hand there so this focuses in. There we go. And 20 milliamps, or 0.02 amps, is the working current across each LED. Now we know in our frequency generator we have an output of 16 volts, and we know that the maximum our frequency generator can put out is 0.1 amp. So 16 volts times 0.1 equals 1.6 watts. So that's what we're putting into their maximum. It could be lower, but that's a maximum. So now, power equals voltage times current. 200 volts now we have times 0.02 amps. equals 4 watts. Our input is 1.6. We're getting 4. Now, again, I'm figuring low voltage. And I'm only figuring 100 LEDs. I'm going to have a lot more than that. So, I mean, we're talking more than double. I don't know, maybe maybe some people aren't getting it out there or what, I don't know, but I'm not going to say it yet, but over Unity, huh? Wasn't me. We'll see, man. Tests need to be done, seriously, but, you know, I mean, and like I said, this is only 100. So we'll be back. Just wanted to show you that. You know, just adding a note, you know, what goes through my head is my system is a single line with no return. So, now again, this is just my opinion, my observations. I believe, maybe hard to believe, but what I believe is going on is, well, I'm creating this pumping action, okay, and it's looking for that return. Okay, so it's got to draw electrons from somewhere. So it draws them from the air. That's what I think. And when I start adding below, and then I start adding to the ground, and then we're sucking also from the ground. So anyhow, all right, guys, let me continue here, and we'll be back. Okay, just want to show you guys this. There's 100 now, not 90, but 100. And all these guys are lit too. They're just not aimed perfectly. And they're very well lit. But yeah, they're all lit. They are very well lit. Like I said, we're very bright in my lab right now, so it's hard to see them. Plus, you gotta be looking right at them. But there's 75 volts across there. About 15 inches of grounding wire. Now we're at 990 kilohertz. So there's 200 now. So remember, I was talking about my math before. That was with 100. And now we got 200. So ponder that. I still wonder if this thing can power itself. Alright. I guess it's going to take me a few hours to start connecting a bunch of strings of 10 LEDs at a time, because that's what I got to do to make a whole other row on here. Like I said, we've already beat our record of well, in video 2 when I had 350, I only had 150 up here and 200 below. So we've got 200 now. And we are putting out a little more voltage though. Okay, we got 16 volts, and when I had those, well, I haven't added more LEDs yet, but when I had the other LEDs 350, we only had 11 volts output. Now I've got 16. So yeah, maybe I'll see how far we can keep going. I also meant to add that if I didn't already, we do now have them connected together, and they are both connecting to the same point off to the left. So they are acting as one unit now. Okay, as you can see, guys, they're all very well lit. Maybe even bright. There's 200. 12 coils, large diameter. I get about 75 volts from that same spot we were checking. I'm sure I'd get higher voltage here and even higher voltage over here, but that's just picking up from a bridge rectifier laying on top of a wire. Where are we at right now? 0.986 kilohertz, 16 volts output. I'm putting together 40. I got another 60 to put together. Oh my god. Yeah, it's a little bit of time consuming, so I think we'll see if we can break our record yet, and then we'll go on to a larger diameter wire, see if that matters. Alright, I'll see you guys soon. Oh, it's so hot in here. It's always over 100 degrees. I got my fan running usually, but I turn it off right now while I'm filming. So I'll see you guys again soon.